Hello everyone, this is another example of how to use set theory and set theory notation to, in this case, establish an equality of two different sets. So here we're going to decide whether this equality of sets is true, and to do that, we're going to start by describing what this all means. So first of all, what does R cross N intersect N cross R mean? What does it mean? By the way, some notation here, N is the natural numbers, 1, 2, 3, and so on. And R is the real numbers. And of course, the natural numbers are contained in the real numbers. There's a lot more real numbers, but the natural numbers is a subset of the reals. So then what is A cross B? That is the direct product of the Cartesian product of two sets. That is the set of all pairs AB with A in A and B in B. Okay, so this is our notation that we're going to use. Then what does this mean? First of all, R cross N will be pairs of real numbers and natural numbers. And we're going to intersect that with N cross R. N times R, that will be pairs of natural numbers and real numbers. Okay, and then what is the intersection? The intersection will be elements that are in both. So for a pair to be, let's call it alpha and beta, for a pair to be in both, then it has to satisfy both conditions. So the first condition in here on the first coordinate is that it has to be a real number. And this one, it tells you that it has to be a natural number. So what this says is that alpha is a real number and alpha is a natural number. And for beta, what we have, the first condition tells me if it's in the first set, beta has to be a natural number. And if it is in the second set, that second coordinate has to be a real number, and beta is a real number. But now you see, because the natural numbers are containing the real numbers and contain but not equal, if you have a number alpha that is a real number and a natural number, then it just has to be a natural number because, well, this has to be, if you want, what we can say is that alpha has to be in the intersection of the natural numbers and the real numbers, which is the natural numbers because the natural numbers are contained in the real numbers. So this says that this is alpha and beta, and then the condition on alpha, which let me rewrite it here, is that it has to be in R intersect N, and beta has to be in R intersect N, or if you want really to preserve that order, in N intersect the real numbers, of course it doesn't matter, then alpha has to be the intersection of the real numbers and the natural numbers is just the natural number, so alpha has to be in the natural numbers and beta has to be in the natural numbers, but that by definition are pairs where alpha and beta are natural numbers. That is the Cartesian product of the natural numbers by the natural numbers. So we have proved what we wanted to prove, so it is true. Those two sets are equal.